Let's discuss about Perceptron in this video. Okay, so first, Frank Rosenfeld came with this idea of classical perceptron, okay, in 1958. Then this model was refined by Minsky and Papert in 1969. Okay, so so perceptron is just the modified version of the Macaulay-Pitch neuron. Okay, so if we look at the Macaulay-Pitch neuron, so Macaulay-Pitch neuron has like, okay, let's say like have n inputs. Okay, so now in perceptron, the variables are no longer limited to Boolean variables. So this can be any values, real number values. Okay. Okay, so as for now, let's assume this output to be either 0 or 1, just to denote whether this neuron has fire or not fire. But this y belongs depends upon this both the aggregation of those inputs as well as the activation function that we used for this neuron. Okay, so this is this Macaulay-Pitch neuron. So there has been like a little bit modified in this model for the perceptron. So in perceptron, only weights are like added on the weights are added on each of those for each of those inputs. So now these inputs are not just input values, but now it's a weighted input. So it will be like weighted inputs will be fetched into the neuron. Okay, so now let's have a look on this mathematical framework of this model. Okay, so in Macaulay-Pitch neuron, so there was theta, which would define the criteria, like when this neuron will fire or not, and when it doesn't. So even in this perceptron, this theta will be there, just to set a boundary with when this neuron can fire and not. And also there is like one more added portion for as a hyperparameter, that is weight. So for perceptron, there are like two learning parameters. So one is weight. So this weight is a vector of all those weights. Okay, and then theta itself is again a learning parameter for this model, and it's a thresholding value. Okay, so let's see the mathematical framework for this perceptron. Okay, so y will be either 1 or 0, just to denote like when this neuron will fire or not fire. Okay, so it will be 1 when the neuron fires. Okay, so and if I equals to 1 to n, and now there is weight. Okay, wxi is greater than theta. So yeah, so if this weighted values, sum of the weighted values, if it's greater than theta, then the neuron fires, and if it's smaller than theta, then it doesn't fire. Okay, so now let's rewrite this equation to make it more simpler and then more general, in a more general form, like rewriting the equation more general form, in more generic form. Okay, so okay, it's like this. So let's bring theta in this side and on the left side. Okay, so that will be like greater than 0. Okay, so let's make it like 1, let's like we can multiply with 1, okay, and then just a little bit changes over here. Okay, so let's assume this is x naught and this as the w naught. Okay, so x naught equals to 1 and then w naught equals to minus theta. So then now this can be even included inside this inside the summation. Okay, so now it can be rewritten as now I starts from 0 to n, and now wi xi is greater than 0. Okay, so where these values are there. Okay, let's write in vectorized form. Now in vectorized form, okay, if we expand this equation, okay, so let's assume w as the weight vector, which is the collection of all those weights, okay, and x is the vector of all the inputs, x naught, x1 to xn. Okay, so now if we multiply, if we multiply those vectors, then it will be okay, sorry, give me a second. It's okay, so now we have we are trying to reduce that equation into vectorized form. Okay, so we have I equals to 0 to n and then w xi. Okay, so this can be written as and then 1. Okay, so because x naught is 1, then x1, x2, okay, then xn, and w naught is minus theta, okay, and x naught equals to 1. So we have to remember this. Okay, so now this can be written as, okay, so let's highlight this. Okay, so this can be written as transpose x. Okay, so yeah, so this is the vectorized form of this equation. Okay, so now the perceptron can be written as in a vectorized form. Like it can be written as like y equals to 1 or 0 if is greater than 0, okay, and the fire doesn't fire and the neuron doesn't fire if this multiplication dot product of the weight and the input is less than 0. Okay, so this is the refined perceptron model.